Okay, in this video I'm going to implement the p-median algorithm in MATLAB. The argument for this program should be the distance matrix and the number of cells required. For example, if I have this distance matrix and the number of cells required is 2, the solution should be like this. So, our program will look like this. First, we have to put in our inputs, that are the number of machines, the distance matrix, and the number of groups. For this example, the number of machines will be 6. This will be our distance matrix, and we will have 3 groups. Afterwards, there is a declaration of variables. These variables are used in the procedure part. So B represents the decision variables, and C is every possible seed machines combination with the number of machines and the groups that we want from these machines. C is the number of groups. D is the number of combinations that we get with our machines and our groups. E will store the distance from the seed machines to the machines that need to be assigned. Double K will store the indices of the machine grouping that needs to be put in the matrix B. Triple K is used because we need to store these indices for every combination of machines. And also double B is used because we need the decision variables of every combination of machines. Then there is the procedure part. Let's see how the procedure works with an example. So the first for is used to access the combination of machines for every combination possible. In this example, we will use the machines 4, 5, and 6. For every one of these machines, we will need to get the distance matrix to every other machine. So, for machine 4, we will have to access the distance from the machine 4 to every other machines, and so on. For machine 5, we will need to have this distance, and also from machine 6. Afterwards, we will need to access the index of the minimum distance from machines 4, 5, and 6 to the other machines. In this case, to machine number 1, we see that the seed 4 is the one that have the minimum distance. From machine 2, our seed is machine 5. To machine 3, our seed is machine 4. Machine 4 is assigned to 4 because it's the seed point, and also 5 and 6. This is accomplished with these 2 for loops. We see that this part of the code is used to access the distance of every seed machine, and this part of the code gets the index of the machines that have the minimum distance. In the next step, we need to assign these indices to the matrix B. So we can do this using this part of the code. We see that in this part we managed to get the index of the machines that are assigned to every seed machine. For example, machine number 1 is assigned to machine 2, machine number 2 is assigned to machine number 5, 3 is assigned to 4, and 4, 5, and 6 are our seed. This for loop is used to assign these ones to the matrix B. Here we can see that machine 1 is assigned to the seed point 4, machine 2 is assigned to the seed point 5, and so on. At the end, we can see that this is the matrix B that we wanted. This matrix B is then stored in matrix double B, and then we have to redo all the loop again. After all 20 iterations, we will have our solution that will look like this. Here we can see that if we multiply the matrix B from this case to the distance matrix M, we get to the solution. And we see that the distance in this case is 6. But this distance is not the minimum. In this part of the code, we can see that double T makes the summatory of all the elements in the distance matrix. Then double S searches in this double T for the minimum distance. And double B can access to every layer of the matrix double T to see where is this distance. So we can see that for this case, the seed machines 1, 5, and 6 make the minimum distance of every possible combination. And finally, we can see one more time how machines are assigned to these seed machines, and our final solution will look like this. And now, if we want to have two groups of machines, we can change this number, and we will see that our solution will look just like this. So our code is correct.